What is climate change? Climate change is weather conditions within a region including temperature, wind velocity, precipitations, and more, averaged over a long period of time.
The relationship between climate change and physics. The Earth's temperature depends on the balance between the energy from the sun entering and leaving the planet's system through the light rays.
The energy from the sun is absorbed by the Earth's system, causing the planet to be warm. When absorbed energy is released and reflected back into space, it causes the Earth to cool off from the warmth.
Some changes in the Earth's balance. Variations in the sun's energy reaching the Earth. There can be changes in the reflectivity of the Earth's atmosphere and surface. Changes in the greenhouse effect, which can affect the amount of heat retained by the Earth's atmosphere.
Greenhouse gases, a gas in Earth's atmosphere that absorbs and prevents the escape of radiation as thermal energy. Examples include carbon dioxide and methane. These gases absorb and re-emit infrared radiation, which are known as greenhouse gases.
Why are these gases so important? Without the greenhouse effect, Earth would be too cold to support life as we know it. The absence of greenhouse gases in the atmosphere would result in a much colder Earth, so an increase in greenhouse gases will produce a warmer Earth.
Earth's temperature. Scientists know which wavelength of energy each greenhouse gas absorbs, and the concentration of the gases in the atmosphere, which helps them calculate how much each gas contributes to warming the planet.
Carbon dioxide causes 20% of Earth's greenhouse effect. Water vapor accounts for 50% and clouds account for 25%. The rest is caused by small particles and minor greenhouse gases like methane.
What causes carbon dioxide to enter the atmosphere? Around the world, climate change and the increase in carbon dioxide in the atmosphere is partly due to anthropogenic human activities. Human activities such as burning fossil fuels and greenhouse gases causes carbon dioxide to enter the atmosphere.
The carbon gas remains a gas at a wider range of atmosphere temperatures than water. Carbon dioxide molecules provide the initial greenhouse heating needed to maintain water vapor concentrations. When carbon dioxide concentrations drop, the Earth cools.
Likewise, when carbon dioxide concentrations rise, air temperatures go up, and more water vapor evaporates into the atmosphere. So while carbon dioxide contributes less to the overall greenhouse effect than water vapor, scientists have found that carbon dioxide is a gas that sets the temperature.
Rising carbon dioxide concentrations are already causing the planet to heat up. At the same time that greenhouse gases have been increasing, average global temperatures have risen to 0.8 degrees Celsius since 1880. The temperature depends on the amount of how much more carbon humans release into the atmosphere.
Where does most of the carbon dioxide go? The carbon dioxide gas produced has to go somewhere. 55% of the extra carbon in the atmosphere are taken up by plants and oceans.
A lot more of carbon dioxide will stay in the atmosphere for many thousands of years, creating thick layers. The carbon cycle affects different reservoirs in different ways.
Once the sun's energy reaches Earth, it is first intercepted by the atmosphere. A small part of the sun's energy is directly absorbed by certain gases. The rest of the sun's energy is reflected back into space by clouds on the Earth's surface.
A key change is that variability of the solar radiation at a particular location that increases dramatically by the spectral content of the light and the angle from which light is incident on the surface.
How does this affect humans? The temperature in the Arctic is rising far more rapidly than the rest of the world. This is due to the amount of carbon dioxide building up in our atmosphere.
Years ago, only 30% of the overall light energy from the sun was being absorbed in the Arctic. The other 70% was reflected back from the ice's high albedo into space. Now, only 20% of the sunlight's energy is being immediately reflected back into space, while the other 80% is being absorbed by the ice.
The carbon dioxide builds up in the atmosphere and does not allow the light energy to escape, bringing it back to the surface of the ice, causing the Arctic to heat up faster.
Created using Powtoon.